All right, here we are. Inertia, part two, mass versus weight. Let's not confuse that with volume, something we really don't use very often in physics. We're going to start off with a video clip I found, and I think this is a good intro to it all. Here we go.
Mass versus weight, two measures for an object. They're not the same, let's all see why. To determine the mass, we use a balance to do it. We use a scale to measure weight. Measured in grams or in kilograms. It's all about how much stuff the object has. Grams or kilograms, they're the units we use for mass. Newtons are for weight. Weight's the measure of gravity's pull on the object. So you can see, mass and weight aren't the same thing. Weight is the measure of gravity's pull. In contrast to weight, mass tells us how much matter the object has. Mass, measured in grams or in kilograms. It's all about how much stuff the object has. Grams or kilograms. They're the units we use for mass. Newtons are for weight. Weight's the measure of gravity's pull on the object. Mass and weight, they're not the same. Mass and weight, they're not the same. Mass and weight, they're not the same. Grams or kilograms, they're the units we use for mass. Newtons are for weight. Weight's the measure of gravity's pull on the object, yeah.
There you have it. Think about what he was talking about. Mass is the stuff, weight is gravity's pull. Now how does this play? Why is this inertia part two? Because inertia is mass. Twice as much mass, twice as much inertia. If you remember, an object wishes to stay at rest, or an object wants to keep moving. Straight line, constant speed. Mass measured in kilograms, weight measured in newtons. So let's see. If I have an object that's 1 kilogram of mass, and I have another object with 2 kilograms, what's going to happen? Well, what happens to the amount of inertia, I should say, when you compare them? The one with twice as much mass has twice the inertia. So let me ask you this. Which has more mass? A kilogram of lead or a kilogram of feathers? Yeah, they're both 1 kilogram. That's mass. Neither. They're the same. Let's see. So which has more inertia? kilogram of lead or a kilogram of feathers? Of course, that should be easy enough. Neither, because why? Mass is inertia. What about volume? If you remember the intro slide, volume. Not to be confused, volume doesn't play much of a role. You can have two objects the same size, and that's what volume is. It's the size of the object. However, what you put inside that object will determine how much mass it has. So mass is the amount of stuff. So which has more volume? Well, kind of a tricky question. If we have the same amount of mass, both a kilogram, I think it's obvious that lead, anybody that's held on to lead knows it's very, very dense and very heavy. So a kilogram of lead doesn't take as much volume. Therefore, which has more volume? The feathers. Watch this video and figure out where's the inertia? What's going on?
I love the holiday season. See you in spring, Toes.
Yeah, where's the inertia? Well, Homer just ate a bunch of food. He gained a lot of mass. So he gained a lot of inertia. How about this one? Which is going to change, the mass or volume? And, we forget about air, okay? Let's get to the meat of the matter, not the minutia details of things. Let's look at the big picture.
Most of my life I've had to live with the shame of being a screw-up. But now as I stand here with the award for the district's safest bus driver, well, it's like a dream come true.
Otto, wake up!
Huh? So, who's good at keeping secrets?
Hopefully you figured out we changed the volume. Yeah, one could argue you lost some glass due to the windows breaking, but let's look at the big picture. The obvious thing that changed was the volume. So we still have all the same metal there. We just compressed all that metal and stuff into a smaller size. Said weight. Weight is how gravity pulls on an object. Well, you have to have some resistance to that weight, right? If you're jumping out of an airplane, you are weightless. You got to push on something. So as we look at our pictures here, this guy in space, he's not pushing on anything. Even though there's a scale there, he has to push on it. Therefore, he's weightless. Go to Earth. He weighs 120 newtons. That's what we measure weight in. Go to the moon. Only weighs 20 newtons. What does that tell you about the amount of gravity on the moon? It's less. In fact, it's about 1/6 that of the Earth. As you can see, the 20 newtons is about 1/6 of 120. So you weigh 1/6 as much because there's 1/6 the gravity. So let's say we're holding up a spring scale, holding a lead ball up. It's found to measure 30 newtons. What is that spring scale measuring? Well, the key is here. It's in newtons and it's a scale. Remember from the video. Of course, it's weight. What causes weight? Yep. Gravity. Gravity's pulling on you. However, you have to have a resistance to that gravity.